Here we have two parallel lines L and M. I'm making few figures here. So one is this parallelogram. Let's name it as ABCD. I'm also making triangle. Here I have a triangle. Let's name it EFG. Let's make a pentagon also. Okay, so this is one side, second side, third side, fourth side, and fifth side. So 1 2 3 4 5 6. Okay, it's hexagon, sorry. So 1 2 3 4 5 6. So I have made a hexagon here. Let's name it L M N O P Q. Okay, let's make one trapezium also. Let it be here, and the name of this trapezium is ACNL. Okay, so I have made 4 types of polygons here, and you know, this is a quadrilateral, so it's gonna have 4 heights. Depends upon how it's in, which are you choosing as the base. Okay, but here the height of this trapezium, as this is given parallel to this, here I have put the marks. Okay, so the height of this this trapezium with respect to base NC or with respect to base LA is actually the perpendicular distance between these two lines. Okay, and let this perpendicular distance be, suppose the distance between L and M be H. So what is the height of this trapezium with respect to base NC? It is H. Okay, because it starts from one parallel line and ends at the other parallel line. Okay, similarly, what's the height of this parallelogram? It will have 2 types of height, one with respect to these bases and the other with respect to these bases. So with respect to base CD, what's the height? Okay, so it is the base is on the line M, and the parallelogram goes till the height till line L. That means again the height corresponding to this base is H. Here height corresponding to the base EG is also H, and here the height corresponding to base LQ. So that this is, if we take this as the base, any one of them can be taken as the base, and with respect to every base the height is gonna be different. Just try to look it in that manner. Suppose there is a door and we want to, and this figure want to enter the door. Okay, so any one of them can be taken as the base. No, we do enter the room through our feet, but this is a triangle and any one of them can be the base. So if this is the base, how long should be the door? This should be this much long. And if this is the base, how long should be the door? This should be till here, from here till here. No, we have already discussed it, how to find out the heights of the polygon. So what I'm trying to teach here, that the height of all of these polygons is same. If I make a, suppose I have one more triangle here. Okay, and let's call it X, Y, Z. Okay, so base is XY, but is the height of this triangle H? No, because it starts from there and it doesn't go till here. So its height is less than H. So this is what I mean to say when I say that the figures lie between the same parallels, then their height is gonna be same. So it is gonna be same only if the base is on one parallel line and the topmost tip or the vertex or the side is on the other parallel line. Okay, the parallelogram TMDC. Okay, so its base is CD, but its height is not H. No. So these two parallelogram ABDC and TMDC, they have the same base but not the same height. Okay, so please understand what do I mean by height same when the figures lie between the same parallel. So all of them have the same height. Do the areas is gonna be same? None of them have gonna have their areas same. Okay, see, their area will be same or not, that entirely depends upon their formulas to find out area. What's the formula for the area of trapezium? Area of a trapezium is half into sum of parallel sides. Okay, and the sum of parallel sides, what's the parallel sides here? LA and NC. So it's gonna be LA plus NC into perpendicular distance between those, means height, means into H. So how do we find out its area? Half into LA plus NC into H. Okay, and how do we find out the area of this parallelogram ABCD? It's gonna be base into corresponding height, that means CD into H. Okay, and this triangle is gonna be half into base into corresponding height. So their formula is entirely different. No, so beta, if we have this parallelogram here APNC NC, and this trapezium here LACN. So what can we see? Their bases is same. You can see NC is in both. So their base is same and their height is also same. Okay, their height H is also same, but their area is not same, because the base and height decides the area only in case of a parallelogram, not in case of a trapezium. Area of trapezium is not decided by NC and H. LA is also the factor. Okay, that's why the name of this chapter is area of parallelograms and triangle. If the base is same and the height is same, we can only discuss about area of parallelograms and triangle. Okay, not about the other figure. Even we cannot find out its area. Base and corresponding height doesn't give its area. Okay, we need to find out some other formula for that. So in your first question, many of you were doing some mistakes. They were not looking whether it's a parallelogram or something like that. They were equating the area. Okay, in fact, if you have suppose this triangle here, so this triangle and this parallelogram have the same base and same height, which is H, but will the area be same? No, because in the formula there is a half factor in triangle. Okay, whereas in parallelogram it's only base into corresponding height. So what's the relation between their area? The area of this triangle is half of the area of the parallelogram. We have already discussed it. Okay, so through this I just want to tell you that area of parallelograms and triangle can be spoken about if base and corresponding heights are given, not the rest. So here we have question 1. Okay, so what is given to you? You have been given a parallelogram, okay, the outer one and this smaller one, and you have been given this triangle also, and this is given equals to this, no? And you have been asked to name the polygons that are equal in area. So whom can you talk about? You can only talk about parallelograms and triangles. Okay, so whose area is gonna be same? See, this parallelogram and this bigger parallelogram, they have the same height. Okay, A, B, C, D and E, F, G, D. They have the same height, but their base is not same. So the area cannot be same. Okay, because the area of parallelogram is, so here the area of parallelograms are not equal, but yes, area of this triangle is half of this parallelogram, no? Why? Because ABCD and PCD, they have the same base, okay? They have the same base and the same height. So this, its area is gonna be, area of this triangle is gonna be half into DC into H, and area of this parallelogram EFGD, it's also gonna be base into corresponding height, and their heights are same, okay? But DG is half of DC, so this is also half into DC into H. So there was only one pair, and that was this area of parallelogram EFGD was equal to area of triangle DPC, and none other were equal. Somebody was taking this also, FBCG. Okay, yes, the basis of this parallelogram and this trapezium, this is a trapezium here. Okay, so their bases are same and their heights are same, but the formula for area of trapezium is not based on base into corresponding height. So we cannot say. So the only result here was this one. So this was all about question number 1.